Let's now learn how to work with the basic functions sequence, paste and replicate. Let's start with the sequence or seq function. You will probably not use the sequence function so often on your own datasets, but it's a great one to get a feeling about how R works. Focus not only on the function itself, but also on the skilled usage of arguments. Different arguments allow a function to be tweaked quite a lot. With this function we will use at least 4 different arguments in various constellations, which will give different results. Since we are using this one for the very first time, it is wise to consult with the R-help. We learn that we are dealing with a sequence generator for regular sequences. That is, of course, what we would expect. The first 2 arguments of the function are from and to. Both have a default value of 1, which means that in case we run the empty sequence function, we would get a sequence from 1 to 1, which gives, of course, 1. If we now specify those values, say we want a sequence from 3 to 5, we can either run the function without argument names, or we can state from 3 to 5, which gives us those 3 integers over here. Indeed, it is 3, 4 and 5 as the output, which is exactly what we would expect. Now, there is another way in how we can reach that result. We can indicate that we want a sequence starting from 3. That's not new at all, but in this case we do not use the to argument. We use the length argument instead. We say that we want a sequence of length 3, which should give us 3 integers in a regular sequence, which is the exact same as the previous result. We can take it a step further and we can indicate that we are not satisfied with the default steps of 1. In this case we want a regular sequence with 0.5 as the step unit. So we are using the by argument to indicate that. And as you can see, in this case we again get 3 numbers, but those are not integers, they are numeric, starting from 3 and ending at 4 with 0.5 as the second value. As a reminder, the order of those arguments does not matter as long as you indicate the argument name. Here I'm simply switching by and length, but it does of course not change the result. Again, we have a sequence from 3 to 4. Alright, so the next function we will take a look at is the paste function. This one focuses on characters or strings, in other words. Characters are communicated in quotes in R. So if we check out the help section for the paste function, we learn that it is about concatenating strings. That means bluntly, anything you feed into the function is turned into a vector of characters. For example, if we type paste 1 to 4, we now have a vector of 4 character values. We can check the class by running class paste 1 to 4, which indeed confirms that this whole vector is not numeric anymore, it's a character class. This is important information because character allows totally different sets of operations than numbers. It does not make any sense to square a string or do some t-test on a string vector. Let's now see how we can tweak that function a bit. We could, for example, use the paste function to fuse several string components together. Say in the next example we have the letters X, Y and Z, and we want this to be repeated and numbered 10 times from 1 to 10. Therefore, we are indicating X, Y, Z in quotes, and then we are using the sequence 1 through 10 indicated with those double dots. This should give us 10 strings. And we indeed find those numbered strings down here in the console, so it worked out perfectly fine. We can of course do the same thing with a random sample of numbers and characters, like I do here. I put this vector on the second position of the paste function, so we would expect a vector length of 5, due to the length of this component over here. And indeed we get the character vector output in the console. We have x, y, z repeatedly on the first place, and on the second spot we can find all those components from over here. By the way, if you're not satisfied with the space between the components, you can use the sep arguments like I do over here. Sep with empty quotes will eliminate the space between the two components. So the output now looks like this. The numbers are now seamlessly integrated after the XYZ string. By the way, what do you think this could be useful for? Well, sometimes you might need to make numbered characters for a plot legend or some stats tests. In order to avoid typing too much, especially with long vectors, you could use this method and save some time. If you want to replicate single elements of whole vectors or lists, you might take a look at the replicate function. If we check out the help section for the function, we learn that it has a very simple structure. The first argument is x, which is the data vector, and then we also have times, which is the number of repetitions. As an example, we can specify a 3-value vector within the function. In this case we state rep, which is the name of the function, round brackets and c for concatenate. Again, with this c, we are saying that in the next brackets we have a vector, which here is simply 3, 4 and 5. We close those first round brackets to make sure that this is recognized as the first function argument. And then we state 3 after a comma. This means we want this vector to be repeated 3 times. And indeed, as you can see down here in the console, we have this vector repeated 3 times, amounting to a total length of 9. We could of course also code it another way. Here I'm simply saying that I want all the numbers from 1 through 10, again repeated 3 times. I'm using the argument name here, which is times. Note that in this case we do not need the c, since R recognizes that 1 through 10 is a vector sequence. And the output now has 30 values. Now in the next example we are going to code it closer to a realistic scenario. Here we are creating the object x at first, which is just 3 numbers. And then we put x, the object name, in the function. That makes the code of the replicate line shorter and the whole code gets easier to read for colleagues. Note that in this case we are also going to use the each argument instead of the times argument. As you can see, in this case the order of the repetition is different. In the output we learn that each single integer is repeated 3 times before the calculation jumps to the next one. The total length is again 9, so it's only the order of the repeated values that is different. We could of course also combine those arguments. In the next case we are aiming at a total length of 3 times 9, which is 27. The general idea here is to again use the x object with those 3 integers. But now we want again each integer to be repeated 3 times, and this whole procedure should be repeated another 3 times. We are stating x as the data, argument each is 3, and we need argument times again, which is again 3. And if we run it, we indeed get a vector of 27, which is exactly what we would expect. Alright, so this was the replicate function, which allows you to multiply vectors or lists in various ways. Next, we will tackle a very important topic, namely how to identify the index positions. Just a brief reminder, the index position is the observation number in a vector. So let's say we have a vector x with the numbers from 4 through 20, a very simple integer vector. The whole thing has a length of 17, so there are 17 index positions available in this vector. The first thing we are going to do is to check out which index positions have a value of 10. For that reason, we need to use logical operators. In R, we are using the double equal signs for an exact match. The function we need here is the which function. So let's state which, then brackets, x, which is the name of our vector, double equal signs, and 10, since we are looking for the exact match of 10. If we run this whole thing, we learn that position 7 has a value of 10. In this case, we only get one index position, but of course it is possible to get several index positions with a value of 10 as a result. So that was how to extract the index position. But what if we want to perform this operation the other way around? What if we have the index position and we want to learn the value behind the index position? Well, that is the great moment of the box brackets. With a box bracket, you always identify the index position. Let's say we want to see which value is on position 3 in our vector. Therefore, we just need to state x as the vector name and in box brackets 3 as the index position. If we run this line, we learn that we have the integer value of 6 on this position, which is of course correct since the whole vector starts at 4. Box brackets are very important for this purpose. Data filtering on data frames or other object classes works the same way. For each dimension of your object class, you would need a value. That means if you work with a data frame, you need a value for the column and one for the rows, which you can specify between those box brackets.